Okay, let's give you guys some more practice. So in this video, I'm going to give you two questions. The first one will be this, and the other one will be right at the end of the video. Find the Taylor series for this function centered at c equals 2, and this is your Taylor series here. Okay, so find the Taylor series. So press pause and have a go. Okay, so to do this, we're going to make use of this formula here. This is your Taylor series here. So when n equals 0, we would put this into here. So this whole thing to the power of 0. So it's going to be 1. So this whole thing here will be 1. Put 0 into here. This is going to be 1. So put 0 into this thing here. So f of 0 is really your original function. Your original function evaluated at 2. So when you put 0 into here, it will be the original function evaluated at 2. So this is your original function. This is your original function evaluated at 2. So we need to put 2 into here. Put 2 into here, so that will be 2 to the power of 4 plus 6. So this will be 16 plus 6. Hang on, let me think. Oh yeah, 16 plus 6 is 16 plus 6. That will be 22, and then take away 1. That will be 21. So that will then give you 21. Now for the second term, it would be you putting n equals 1 into here. So n equals 1, put it into here. So you have this thing to the power of 1. Put 1 into here. 1 factorial is 1, so that would be 1. And then put 1 into here. So f of 1 really means your first derivative evaluated at 2. So this is your first derivative evaluated at 2. So we've got to put the 2 into here. So that will be 8 times 4. That would be 32 plus 3. That would be 35, and then we've got to, so this block here will be 35, and then you divide it by 1, so that's 35. So this whole thing here will be 35, and then your next term, well, you would put n equals 2 into here. So this put n equals 2 into here. So you've got this thing squared. You've got this thing squared, and then this thing here will be, later on we've got to divide it by 2, and then put this into the n here. So f of 2 is really your second derivative evaluated at 2. Okay, so looking at your second derivative here, we've got to put the 2 into here. So that will be 4. This thing here will be 4. So 12 times 4, that will be 48. And then we've got to divide it by 2 here. So 48 divided by 2, so that will then give you 24. And then n equals 3. N equals 3 is the same thing. So it would be this thing to the power of 3, blah blah. Your Taylor series will be this. Anything beyond this, if you keep on differentiating this, it will be 0, 0, 0. So there's nothing else beyond. As you head towards infinity, there's nothing else. So your Taylor series is given by this. Okay. So next question. So exactly the same thing, but rather than centered at 2, we're going to center it at 0. So really, because it's centered at 0, really I'm asking for the Maclaurin series. Okay. So find the Maclaurin series for this function. So press pause and have a go. Well, the Maclaurin series for this function is itself. It's the exact same self. Okay, so the Maclaurin series for this, when you evaluate it at 0, it will give you the same thing. So the Maclaurin series for this function is this. Okay.